Let us look at partial fractions. We have already seen the case where distinct linear factors are there in the denominator, repeated linear factors are there. Now let's look at irreducible quadratic factors. Let's say we have x square plus 1 divided by x times x square plus 2. Since each partial fraction must itself be a proper rational function, the degree of its numerators must be less than the degree of its denominator. Therefore, for an irreducible quadratic factor, the numerator must be a linear polynomial. So we take one less. So which means for a quadratic, it's a linear expression. So if the denominator factor is linear, the numerator is constant. That is why we were taking A, B, C. If the denominator factor is an irreducible quadratic, the numerator is linear. If the denominator factor is an irreducible cubic, the numerator is quadratic. So in general, the degree of the numerator is 1 less than the degree of its corresponding denominator factor. So because of this, x square plus 1 divided by x times x square plus 2, we take it as equal to ax plus b by x square plus 2 plus c by x. And we are taking a linear numerator. Why? Because x square plus 2 is an irreducible factor. Again, getting rid of the denominators, we get x square plus 1 is equal to ax plus b times x plus c times x square plus 2. Simplifying, x square plus 1 is equal to ax square plus bx plus cx square plus 2c. Equating the constants, 1 is equal to 2c, which means c is equal to 1 by 2. Equating the coefficients of x square, we have 1 is equal to a plus c. But c we already know. So 1 is equal to, or we can say a is equal to 1 minus c. That is 1 minus half, which is a is equal to 1 by 2. So what all do we have now? We have c, we have a. We have to find b. So equating the coefficients of x, we get, because if you look at this, there is no x term in the left hand side. So it is 0. And on the right hand side, only b is there as the coefficient of x. So b is equal to 0, which means our sum of partial fractions is x by 2 times x square plus 2 plus 1 by 2x. A is 1 by 2. 1 by 2x plus b is 0. So 1 by 2x. So 1 by 2x means 2 goes down. So x by 2 times x square plus 2. And here we have 1 by 2 x. Now how did we get this? Because here we have c by x. C is 1 by 2. So 2 goes down. Let's look at another example. X square plus 2 divided by 3x square plus x plus 1 times x square plus 1. Now here in the denominator, factors are irreducible quadratics, both of them. So which means we take a linear numerator for both of them. So ax plus b divided by 3x square plus x plus 1 plus cx plus d divided by x square plus 1. Getting rid of the denominators, we get x square plus 2 is equal to ax plus b times x square plus 1 plus cx plus d times 3x square plus x plus 1. Opening up the brackets, we get this. Simplifying it, we get this. Simplifying in the sense, grouping like terms. Now equating the coefficients of x cube. On the left hand side, there is no x cube. So 0 is equal to a plus 3c, which means a is equal to minus 3c. Coefficient of x square is 1. is equal to b plus c plus 3d. Equating the coefficients of x, 0 is equal to a plus c plus d. So which means substituting and simplifying, we get d is equal to 2c. Equating the constants, we get 2 is equal to b plus d. So b is equal to 2 minus 2c. Okay, now we have to get a, b, c, d. So b plus c plus 3d equal to 1. We know b is 2 minus 2c. D is, where is d? D is equal to 2c. So that means we can convert this into terms with c. So 2 minus 2c plus c is minus c plus 6c is equal to 1. Simplifying it, we get c is equal to minus 1 by 5. D is equal to 2c. So 2 times minus 1 by 5, which is minus 2 by 5. B is equal to 2 minus 2c, which is 2 minus 2 times minus 1 by 5, which is equal to 12 by 5. A is equal to minus 3c. So minus 3 times minus 1 by 5 is equal to 3 by 5. So now we have got A, we have got B, we have got C, we have got D. So substituting it, we get this 3 by 5x plus 12 by 5 divided by 3x square plus x plus 1 plus minus 1 by 5x plus minus 2 by 5 divided by x square plus 1. Simplifying it, denominator 5 is common in the numerator. So we get 3x plus 12, and that 5 we can take it down. 5 times 3x square plus x plus 1. Plus, again 5 is common, so it goes down. Minus x minus 2 by 5 times x square plus 1. And taking minus common out, we get 3 times x plus 4 divided by 5 times 3x square plus x plus 1 minus x plus 2 divided by 5 times x square plus 1. So this is our decomposed rational polynomial. Now, for the fourth case, denominator with repeated quadratic factors. Here what we saw was denominator with irreducible quadratic factors. The fourth is repeated quadratics. So now those quadratics could be reducible or irreducible. If they are reducible quadratic factors, these can be factored into linear factors and then handled using rules for repeated linear factors. But if they are irreducible quadratic factors, that is x square plus 1 to the power of 2 or something like that, then we combine the two rules seen earlier. Repeated factors produce repeated terms. The numerator has degree 1 less than its corresponding denominator factor. So we have looked at converting a given rational expression into its sum of partial fractions. And we have looked at different forms in which these rational polynomials may be given to us or we may encounter. That was partial fractions. That's it for now.